Through this video we will see how Valor NPI will be used to left shift a new product introduction DFM analysis from manufacturing into design. Typically, DFM analysis is performed late in the design process. Typically a full analysis will be performed towards the end of the process, but this generates a lot of issues that are difficult to fix that late in the design process. With Valor NPI now running concurrently within Expedition in VX 2.4, we can run these analyses at the different points through the design process, like component placement or routing, and therefore when we come to the point of final release, we have something that is very manufacturable. So now in VX 2.4 we have Valor DFM and now embedded into the design process. It now is a window that can be run directly from within Expedition, and the analysis will be generated and the results put into the normal Expedition hazards control. We've just run the analysis now, and now we can actually look at the results that are generated. All of the analysis is segmented into the different areas. For example, etch, solder, maybe component, and you can step through these issues and actually see live within Expedition as it takes you through each of the issues that have been highlighted. At this point you can decide, should I correct the issue within Expedition? Do I need to change my analysis and my test limits to decide whether the issue is something that needs to be addressed or not? And step through those changes and decide on a case-by-case basis, which is the ones that need to be addressed and which don't. All the different checks can be highlighted and reviewed. In this particular case, you'll notice we've accepted a number of via annular ring issues, and we'll come back to that when we run the analysis again. As we move through the analysis and the results, we're looking at some stubs. We can look at some slither analysis and again decide whether these issues need to be fixed directly within Expedition or we need to adjust our measurements accordingly. The complete set of Valor DFM analysis is possible within Expedition now. Here we have a sliver analysis where we have a potential acid trap between the pad and the trace. In that particular case, we can decide to move the trace down to create more of a gap between it and the pad. There's also a lot of via wide trace narrow pad analysis that can be performed as well, as we can see here. So in this particular case we have a trace that's very wide, wider than the pad itself. The problem that this can cause is that it changes the thermal characteristics of during reflow and can cause tombstoning and other solderability issues. There are other checks that can be performed such as solder mask and silt screen. All the complete set of DFM analysis can be performed within Valor NPI, running concurrently within Expedition VX 2.4. When I've completed all of my analysis and I want to run it again, as we're seeing shortly, we're now going to fire that off a second time. That analysis will repeat, but we won't have to review any of the results that I've previously highlighted. You can see them in green here. I didn't have to go back in and automatically highlight those issues. So that's Valor NPI running within VX 2.4. From a design for test perspective, Valor DFT can also be used to left shift DFT analysis into the design process, and not just the layout, but as we're seeing here, also down to the schematic. So here we have a design with a handful of functional test probes that have been added to the design, but most of the nets don't have the correct number of test probes added to them. So we can take that information and export it and use that once we get to PCB layout. Expedition VX can import the test point requirements from a file. That file has been generated by Valor DFT. And that will then set the number of test points for each of the nets. Based on the analysis, this might be one net, a number of test probes per net, but it also can be 0 test probes per net. If Valor DFT is determined that it doesn't need test points on a certain net, then that will save space that can be used for other nets. Here we can run the automatic placement algorithms to set the test point requirements for as many of the nets as possible. If necessary, we can use manual methods to add the test point to the net as well. Once complete, we can re-export the data and now run the analysis against the design and the layout data. So we're now rerunning that analysis. We're going to pick the layout information this time, and now we've got test points coming in from schematic, our functional test points, plus the test points that have been added purely in layout. Once we run that analysis, we can then take a look at the test point analysis and requirements that have been generated after the updates have been performed within layout. And we can see now that a lot of the nets, not necessarily all of them, but most of the nets now have the correct number of test points. So there may be still a little bit of work to do, but the vast majority of nets now have the right number of test points, and see that the right number of test points isn't necessarily 1. We haven't just put 1 test point per net, but there are nets there that have 0 test points, and that is correct because we've determined that we don't need test points for those particular nets. And that allows us to maximize the test coverage for the fewest number of test points on the board.